Section 4. Effective Will and the Zeno Effect. Ironically, William James produced a theory of volition in 1892, which, in psychological terms, very much parallels this approach. He wrote, "I have spoken as if our attention were wholly determined by neural conditions. I believe that the array of things we can attend to is so determined. No object can catch our attention except by the neural machinery. But the amount of attention which an object receives after it has caught our attention is another question. It often takes effort to keep mind upon it. We feel that we can make more or less of the effort as we choose. If this feeling is not deceptive, if our effort be a spiritual force and an indeterminate one, then of course it contributes co-equally with the cerebral conditions to the result. Though it introduced no new idea, it will deepen and prolong the stay in consciousness of innumerable ideas which else would fade more quickly away. The delay thus gained might not be more than a second in duration, but that second may be critical. For in the rising and falling considerations in the mind, where two associated systems of them are nearly in equilibrium, it is often a matter of but 1 second more or less of attention at the outset, whether one system shall gain force to occupy the field and develop itself, and exclude the other, or be excluded itself by the other. The essential achievement of the will, in short, when it is most voluntary, is to attend to a difficult object and hold it fast before the mind. Effort of attention is thus the essential phenomenon of will. Stapp provides support in terms of his version of quantum theory as to how James's theory of volition might work in practice. First, he asks a crucial question. How does this dynamical psychoneurological connection via process 1, which can merely pose a question but not answer it, allow a person's effort to influence his or her physical actions? And he responds that the only dynamical freedom offered by the quantum formalism in this situation is the freedom to perform at a selected time some process 1 action. Whether or not the yes component is actualized is determined by nature on the basis of a statistical law. So the effectiveness of the free choice of this process 1 in achieving the desired end would generally be quite limited. The net effect of this free choice would tend to be nullified by the randomness in nature's choice between yes and its negation no. Stapp claims that a well-known non-classical feature of quantum theory does, in fact, provide a way to convert available free choices into effective mental causation. It's known as the Zeno effect, and it provides a technical explanation as to how quantum theory can explain the efficacy of the conscious will. Stapp explains the Zeno effect in terms of two processes, 1 and 2, which John von Neumann introduced in his version of quantum mechanics. Process 1 is a conscious information-creating process, which has come to be called the collapse of the wave function. Process 2 is deterministic and information-preserving or conserving. Process 1 gave rise to the so-called problem of measurement, because its randomness prevents it from being a part of the deterministic mathematics of process 2. Stapp says that via the Zeno effect, mental effort applied to a conscious intent increases the intensity of the experience. Thus, it is consistent and reasonable to suppose that the rapidity of a succession of essentially identical process 1 actions can be increased by mental effort. But then we obtain, as a mathematical consequence of the basic dynamical laws of quantum mechanics described by von Neumann, a potentially powerful effect of mental effort on the brain of the agent. Stapp explains that the Zeno effect is based on a situation in which an unstable particle, if observed continuously, will never decay. In other words, one can freeze the evolution of a system by measuring it frequently enough in its known initial state. The name comes from Zeno's arrow paradox, which states that because an arrow in flight is not seen to move during any single instant, it cannot possibly be moving at all. Stapp says applying mental effort increases the rapidity of the sequence of essentially identical intentional acts, which then causes the template for action to be held in place, which then produces the brain activity that tends to produce the intended feedback. Stapp also claims that the quantum Zeno effect can, in principle, hold an intent and its template in place in the face of strong mechanical forces that would tend to disturb it. This means that agents whose mental efforts can sufficiently increase the rapidity of process 1 actions would enjoy a survival advantage over competitors that lack such features. Stapp claims that the Zeno effect could enable human individuals to sustain beneficial templates for action in place longer than competitors who lack this capacity. Thus, the dynamical rules of quantum mechanics allow conscious effort to be endowed with the causal efficacy needed to permit its deployment and evolution via natural selection. The bigger context within which the classical rejection versus the quantum acceptance of conscious will is that of scientific materialism. Despagna is anxious to emphasize that the advent of quantum theory entails the demise of scientific materialism, the philosophical status of which was always dubious. He says that the doctrine of scientific materialism was based on a plainly unjustified extrapolation from science itself. In fact, although the association of the two words scientific and materialism was always judged too bold by some philosophers, it did, though, have some legitimacy at the time of classical physics. For at that time, physicists thought they could define matter as the ensemble of all atoms plus fields, and deemed themselves capable of formulating their science without any reference, not even implicit, to the states of consciousness, or otherwise said to the sense of impressions of scientific observers. In consequence, the thinkers of that time were justified in their conjecture that matter, thus defined, is the only irreducible reality. Nowadays, though, things are clearly quite different. Stapp similarly criticizes the failure of classical physics to accommodate mind and consciousness within its theoretical framework. In spite of intense efforts spanning more than 3 centuries, the reasons for this failure are easy to see. Classical physics systematically exorcises all traces of mind and its percepts, thereby banishing any logical foothold for recovering mind. Moreover, according to quantum physics, all causal effects of consciousness act within the latitude provided by the uncertainty principle. And this latitude shrinks to 0 in the classical approximation, eliminating the causal effects of consciousness. D'Espagne does consider the idea that the achievements of modern biology may contradict quantum's claims of a metaphysical revolution. The apparent ability of biology to explain life entirely in materialist terms seems to undermine the idea that quantum mechanics has banished scientific materialism. D'Espagne says, "It is true that biologists, to some degree, manage to explain life in terms of physics alone. But at the same time, the principles of that physics have changed so much that fundamentally they can no longer be formulated without some reference, admittedly often implicit, to sense impressions, and hence to the notion of the human mind. The fact that biology is principally concerned with large molecules, for which the classical laws and concepts, easier to handle than their quantum counterparts, in practice provide quite adequate approximations, does not affect the fundamental significance of this epistemological change, though it may for a time obscure it in some respects. The truth is that insofar as materialism claims to be more than just a philosophically irrelevant methodology, it can be considered as a scientific conception, that is to say, a conception that science supports. In other words, It's the fact that modern biology deals mainly with large molecules, which disguises quantum's full impact on it. But when it comes to the study of consciousness, this apparent quantum immunity of biology in no way diminishes the implications of quantum's insistence on a role for consciousness in physical theory.